Namaskar. Welcome in this lecture series of Software Engineering Fundamentals. This is Dr. Bright Keswani, as Professor in Computer Science and Engineering Department, Suresh Gyan, Vihar University, Jaipur. In this series, today we will discuss about the structured analysis and design tool. These are the learning objectives and learning outcomes of this lecture. Through this lecture, you will learn all insights about the structure analysis and designing tools in detail. After the completion of this lecture, you will be able to understand the importance of analysis and designing tools and why effective structuring and designing is required. You can understand it and why we are developing this software system in a structured manner. Why it is so, why it is important. So we will understand this thing also through this lecture. These are some important points to be discussed during the lecture. The first thing we will discuss about the structure analysis and structure design. In this topic, we will discuss about I will give you the overview about this topic. Then we will discuss about the goals and benefits of structured analysis and structured design. Then in detail, we will discuss about the structured analysis and its various tools. And lastly, we will discuss about the structured design and its various tools. First of all, let us discuss about the brief description of structured analysis and structured design. As you know, that software development has become increasingly complex in last decades, and in addition to that, the economic pressure and competition for software companies has grown. Software engineering is the effort to apply disciplined and repeatable engineering techniques and methodologies to development of software in order to cope with complexity and produce high quality software systems economically. So what is important when we are making a software when we are working on a software project, what is important? Timely completion of the project is important. Maintain the quality is the major issue, which is to be achieved through the development of software, and user requirements are also important, plays an important part. Applying structured analysis and structured design to a software development process can help producing a complete and consistent specification that will in turn lead to fewer problems in the implementation stage. Okay, so we can say that structured analysis is the activity of deriving a structure model of the requirements of a system, and structured design is the development of a blueprint of a computerized solution to a problem having the same components and interrelationships as the original problem had. Okay, so you can say that analysis in a structured manner, analysis with the help of a structured model of the requirement is the part of structured analysis activity, and development of a blueprint of the software solution to a problem having same components and interrelationships as the original problem had. You can call it as a structure design. Okay, so both structure analysis and structure design techniques are based upon the idea of a black box description of a system. Okay, Structure analysis and structure design, you can say, is a diagrammatic notation which is designed to help people understand the system. And the basic goal of structured analysis and structure design is to improve the quality and reduce the risk of system failure. Nowadays, because complexity introduced in the software, in the problems domain, so there is a risk of system failure. So what is the aim of SA and SD? The aim of structure analysis and structure design is to improve the quality and reduce the risk of system failure. And it established the concrete management specification and documentation also. It focuses on solidity and maintainability of the system. Basically, the approach of structured analysis and structure design is based on the data flow diagrams, and it is easy to understand software structured analysis and structure design, but it focuses on well-defined system boundaries, whereas JSD approach is too complex and does not have any graphical representation. So what is important in these technologies, these techniques, data flow diagram. So you can say that it is a diagrammatic notation of representing the system. Okay, and it combines commonly known as SAD, system analysis and system design, and it mainly focuses on 3 points. First is system, second is process, and third is technology. Okay, so these three things are very important when we are doing the structure analysis and structure design. We should keep in these 3 points in our mind and develop the software around these 3 things: system, process, and technology. Okay. Next topic is goals and benefits of structured analysis and structured design. So the major goal, as far as goal is concerned, the major goal of structured analysis and structured design is to improve software quality and reduce the risk of failure, as I earlier said. Behind this primary goals and some secondary goals are need to obtain a clear and complete specification, because without the complete and clear specification, you cannot made a well very good or quality design. Okay, so when you want to make a quality design of the software, you should obtain a clear and complete specification and requirements from the user, from the client organization. Okay. Second is documentation for the system, which is again very much important, but the secondary goal, because what is the primary goal? To improve the software quality and reduce the risk of failure is the primary goal of structured analysis and structure design. And the secondary goal is documentation for the system. So need to obtain a clear and complete specification is the first secondary goal, and the second secondary goal of SASD is documentation for the system. Okay, therefore SASD tackles reliability, flexibility, maintainability, and effectiveness goals by making visible and precise model that show analysis and design information. Okay, so these are some goals of structured analysis and structured design. Let us discuss about the benefits of structured analysis and structured design. There are several benefits, but major 3 benefits are: SASD creates map of the system, and these maps can be used for traceability, maintenance, and enhancement activities in the future. Okay, so what is important? A blueprint. Making a blueprint is important. Making a system as a quality system is important. Okay, so SASD creates map of the system, and these maps are can be used for traceability, maintainability, and enhancement activities in the future. The second benefit of SASD is that SASD places uh, emphasis on analysis and design activity rather than implementation, and this encourages the project team to be thoughtful about the system's fundamentals, purpose, and the engineering details. So the another benefit that it uh, uh, through this activity, the project team have a clear-cut understanding about the need of the system, the purpose of the system, and their other development-related details, minute to minute details. Okay. The third benefit of SASD is that the project team develops software documentation as they progress through development. So the third benefit is very much important because documentation of the system is essential. There are so many types of documentation. The documentation for user, documentation for the analyst, the documentation for designer, the documentation for testing professionals, documentation for database administrator to design the database accordingly. Okay, so the project team develops software documentation as they progress through development. At every stage, we have a documentation with us when we are working with SASD. Okay, so these are the goals and benefits I elaborated. Let us discuss about structured analysis and its tools. As I earlier stated, that structured analysis provides you the working model, and there are some other objectives, primary objectives of structured analysis. The analysis model must achieve three primary objectives. The first primary objective of structured analysis is to describe what the customer requires. Okay, what are the requirement of a customer, real requirement. And the primary objective of structured analysis is to establish a basis for the creation of a software design. Okay, because the next activity of SDLC after the analysis activity is the structured design activity. So the primary objective, another primary objective of structured analysis is to establish a basis for the creation of a software design. And the last objective, you can say, is to define a set of requirements that can be validation once the software is built. So to provide, to access the, to grab the instructions and the requirements from the end user, from the client is the first need. Second need is to provide the or establish the basis for the creation of software design is the second primary objective. And the third primary objective is to define set of requirements that can be validation. Okay, that can be validation once the software is built. Let us discuss about the tools for structured analysis. There are many notations and graphical symbols are used to describe the partitions of the functionality of the system, and these are some tools which are related to the structured analysis. Data flow diagrams are there, uh, context diagrams are there, event events list is there, data dictionary is there, prime process specification is there, and entity relationship diagram is there, and state transaction diagrams are there. So, in short, we can say that DFD, CDs, uh, DD, P, P for process specification, and ERD and STD are the uh, you can say the basic tools for structured analysis. Okay, let us discuss about the data flow diagram. That is the structured analysis tool. Data flow diagram is a graphical representation of flow of data in an information system, and it is capable of depicting incoming data flow, outgoing data flow, and stored data. Because there are several symbols that shows that incoming uh, data flow, outgoing data flow, and stored data. The DFD does not mention anything about how data flows through the system. Okay, this is the point to be remembered. There is a prominent difference between DFD and flowchart. The flowchart depicts flow of control in program modules, and DFD depicts flow of data in the system at various levels. So this is the basic difference of DFD and flowchart, that the flowchart depicts the flow of control in programming modules, and DFD depicts flow of data in the system at various levels. And DFD does not contain any control or branch elements. So you can say that DFD is a graphical technique that describes the information flow and the transformation that are applied as data moves from input to output. In the simple words, we can say. And the data flow diagrams serves two purposes, that it is uh, to provide an indication of how data are transformed as they moved through the system, is the first purpose. And second purpose of DFD is to depict the functions and subfunctions that transform the data flow. So DFD, you can say, is a important graphical notation and symbolic presentation of the program, or you can say the software. There are many symbols of DFD. We will discuss later. First, we will discuss about the types of DFD. There are two types mainly. Data flow diagrams are either logical or physical. The logical DFD concentrates on the system process and flow of data in the system. For example, in a banking software system, how data is moved between different entities is important. So, logical DFD is concerned with the system process and flow of the data in the system. Whereas the physical DFD shows how the data flow is actually implemented in the system. Okay, so it is more specific and close to the implementation. So there are mainly two types of DFD. Now I hope you understand the meaning of logical DFD and physical DFD. These are the components of DFD: entities, process, data store, and data flow. DFD can present source, destination, storage, and data flow of data using the these set of components. Entities means entities are source and destination of information data, and you can say it is input or output. Okay, entities are represented by rectangles with their respective names. you should mention the name in the in place of entity. Okay, so entities are source and destination of information data. Second symbol is the circle, and it is called as process. Activities and actions taken on the data are presented by a circle or round edge rectangles. So, in different notations, it is the different symbols we are using, but in standard notation, circle will represent the process. Okay, so activities and actions taken on the data are represented by circles. Then data store. Data store, there are two variants of data storage. It can either be represented as a rectangle with absence of both similar both sides, or as an open-sided rectangle with only one side missing. Okay, you can see it in this diagram. There is a one edge, and the second edge is missing. Okay, second side is missing. So you can write the name of the data store here and name of the file here where the data is stored. The next symbol is data flow. Movement of data is shown by pointed arrows, and data movement is shown from the base of arrow as its source towards head of the arrow as destination. Okay, so data flow is the another thing. A data flow is a data item that is flowing from one place to another and is presented by an arrow. All data flows in a DFD should be labeled, and the arrow headed indicates the direction of the data flow. Okay, so data flow is an important part. It should not be empty. The name should be given to mention to all the data flows. Okay, and when we talk about process, a process is applied to data and transforms it in some way, and circle is used to present the process or transformation. Okay, okay. Uh, Let us discuss about data store. A data store is a repository. As I earlier said, it is a repository of data and is represented by a double line. And this data is stored by for use by more or one or more processes, and it may be as simple as a buffer or queue, or as sophisticated as a database. So these are very important components of a DFD. By using these components, you can draw the DFD easily. Okay. There are some steps in developing a DFD. The first step is to draw a context level diagram. Okay. Let us discuss the context level diagram. But first you understand what are the steps in developing a DFD. Okay, first we will complete the DFD notation. So the first step in developing a DFD is to draw a context level diagram. The context level diagram shows the main source, processes, and the scope of the system under development. And the purpose of the context diagram is to conceptualize the general sources and sinks of data. Okay. The second step is to decompose the context level diagram. Okay. So first you should draw a context level diagram, then you decompose the context level diagram. So the context level diagram is exploded or decomposed into second level DFD. Okay. The third step, decompose to a elementary level, and this level of diagram explains in even greater details the actual process that are occurring, and leveling occurs until the detail is described for the system analyst and user to understand the system fully. So when you consider a banking system, you can easily, DFD of a banking system, you can easily understand the steps in developing a DFD. There are, I'm repeating again, there are three steps. First is draw a context level diagram. Second is decompose the context level diagram. And third is decompose to an elementary level, okay, for better understanding. So this is the way to simplify the complex problem. Let us discuss about the context diagram. What is context diagram? The context diagram shows the system under consideration as a single high-level processes, and then shows the relationship that the system has with other external entities like systems, organizational groups, external data stores, etc. Okay, so we can say that a context diagram is a top level data flow diagram, and it only contains one process node, that is process 0, that generalize the function of the entire system in relationship to external entities. Okay, so DFD are used for uh, depict the overview of the entire system, under development to depicting the detailed processing of a single transaction. The context level diagrams, DFD, shows the main sink, sources, processes, and scope of the system under development using DFD symbols. So you can say that uh, uh, context diagram is a summarized form of DFD. Okay, so it shows the system under consideration as a single high-level processes, and then show the relationship that the system has with other external entities. Another name of a context diagram is a context level data flow diagram, or the zero level data flow diagram. Okay, so you can say that a context diagram is the zero level DFD. Okay, so context diagram and data flow diagrams were created for systems analysis and design, but like many analysis tools, they have been leveraged for other purposes. Like for example, they can also be leveraged to capture and communicate the interactions and flow of data between business processes. So they don't have to be restricted to system analysis. A context diagram provides no information about the timing, about the sequencing, and synchronization of processes, like uh, uh, which process occur in sequence or in parallel. So it should not be confused with a flow chart or process flow, with which can show these things. Okay, so remember this thing always, that a context diagram provides no information about timing, about sequencing, and about synchronization. Okay, this is a general you can say the diagrammatical representation of a context diagram. Okay, you can say it is a surface scanning of the system or problem. Let us discuss about some benefits of context diagrams. It shows the scope and boundaries of a system at a glance, including the other systems that interface with it. Secondly, no technical knowledge is assumed or required to understand this type of diagram, because it is a very simple diagram. Then it is easy to draw and amend due to its limited notations. It is very simple. Simplicity is the best feature of this notation. Easy to expand by adding different levels of DFD is another benefit of context diagram, and it can benefit a wide audience, including stakeholders, business analysts, data analysts, and developers. So it is a very useful tool. You can easily draw it, you can easily show it, it is easy to understand, it is easy to expand, it is easy to draw because of its limited notations. And so there are ample of benefits of context diagram. But if you want more details about the problem solution, then you can go for DFT. The next tool is data dictionary. Data dictionary is the major component in the structure analysis method, and uh, a data dictionary in software engineering means a file or a set of files that includes a data's metadata. Metadata means data about data. Okay, it holds records about other objects in the databases, like data ownership, relationship of data to other another object, and some other data. Okay, so you can say that data dictionary is an organized listing of all data elements that are pertaining in the system with precise, rigorous definitions, uh, so that both user and system analyst will have a common understanding of input, common understanding of output, and components of stores, and even intermediate calculations also. So a data dictionary is like any other dictionary in that it defines each data element name, and the data dictionary contains definitions for all data elements in the system being modeled, and uh, it is, you can say, a valuable tool. Okay, so a data dictionary is a repository, you can say. It stores the information about the various data objects appearing on each DFT. Okay, so generally data dictionary format may take a pre-specified format. These are the components of data dictionary. So uh, in software engineering, the data dictionary contains the following information as follows, given in this PPT. uh, Name of the item, it can be your choice. Lies, it represents another name. If another name of the item is present or used, then you can represent the another. You should mention the another name of the element also here. Description part, in the description part you can give the actual text about descriptive text about the element for which the data dictionary is made. Related data items means a relationship with the other data items. You should maintain, you can maintain the relationship, you should show the relationship uh, of any single item with another data item, and the range of value, which will represent all possible answers. Okay, so what is here in this format? Name is here, lies, lies is there, where used or how used is there, content description is there, and supplementary information like type, restrictions, and limitations are there. Okay, so composite data may take the form as a sequence of data items, as a selection from among a set of the data items, and as a repeated grouping of data items. So we can say that a data dictionary may just give a simple description of the data. Okay, these are some features of data dictionary. Um, First feature, it helps in uh, designing test cases and designing the software. It is very important for creating an order list from a subset of the item list. It is very important for creating an order list from a complete item list. And the data dictionary is also important to find the specific data item object from the list. These are some use of data item. It is used for data dictionary. It is used for creating the ordered list of data item. It is used for creating the ordered list of a subset of the data item. It is used for uh, designing and testing of software in software engineering, and it is used for finding data items from a description in software engineering. Okay, so let us discuss about the process specification. What is process specification? The process specification can be used to specify the processing details implied by a bubble within a DFD. The process specification describes the input to a function and algorithm that is applied to the input and the output that is produced. And you can say usually as it is usually written using pseudocodes. Okay, so process specification can be used to specify the processing details, and you can say that it is a method used to document or analyze and explain the decision making logic and formulas used to create output data from process input data. And its objective is to flow down and specify regulatory or engineering requirements and procedures. High, high quality, consistent data requires clear and complete process specification. That's why this tool is very much important. Process specification reduces the ambiguity, allowing an individual or organizations to obtain precise description of executed tasks and accomplishments and validate system design, including the data dictionary and data flow diagrams. So this is the example of, you can see here, this is the example of illustration of a simple process specification. Okay, this is the simple process specification diagram. There are some process specification tools like structured English, decision table, decision tree. Okay, structured English is a you can say it is a collection of simple keywords that clearly describe the three standard control uh, constructs of sequence, selection, and repetition based on the structure diagram flowchart. So, structure in English is consists of sequence, selection, and repetition based structure diagram. And the decision table have are simple and compact mechanism for recording simple decision logic, and it consists of four quadrants: condition stub, condition rules, action stub, action rules. Condition stub means what? All possible conditions that can arise during processes from the condition stub. Action stub, all possible actions that can occur within process in order to execution are listed under action stub. All logical combinations of conditions that can arise in process are listed under condition rules, and each condition is called as a selector. Okay, and action rules are the indicators that select actions to be performed. Okay, so decision table is an important tool of process specification. There are basically three types of decision tables: limited entry decision tables, uh, secondly, the mixed entry decision tables, and finally, the third type of decision table is extended entry decision table. Okay. The second tool is decision tree. Decision tree were first described in 1944 and by the scientist John von Neumann. And decision tree is a tree structured graph that pictures or that illustration of the subsequent observations and definitions that a decision maker possibly encounters during the course of time. So decision trees are similar to decision table, except they are more graphical and they resemble as a tree. A decision tree is usually drawn sidewards with the root of the tree at the left end and the leaves of the tree right end on right end. There are three types of nodes in a decision tree. First is decision nodes, second is change nodes, and third is terminal nodes. Okay, decision nodes presents moments at which the decision makers has to choice between a member of alternative actions denoted by the branches leaves the decision node to the right. And change, as far as change node is concerned, change node denotes points in time at which uncertain events take place. Okay, so the set of events that may occur at the specific node are presented by the branches that leaves that change node. The terminal nodes are the last type of nodes that appear in each decision tree. Each terminal node represents a possible state of the world after a completed episode of actions and events. Okay. Uh, uh, this is all about process specification. Let us discuss about the entity relationship diagram. Entity entity relationship diagram. Uh, that is we are called it as a ERD. The entity relationship diagrams is the means of providing a data model of the system in structured analysis. ER modeling is a data modeling method used in software engineering to produce a conceptual data model of an information system. Diagrams created using this ER modeling method are called entity relationship diagrams or ER diagrams. What is the purpose of ERD? The database analyst gains a better understanding of the data to be contained in the database through the step of constructing the ERD. The ERD serves as a documentation tool, and finally, the ERD used to connect the logical structure of the database to users. In particular, the ERD effectively communicates the logic of the database to users. These are the components of ER diagram: entity, uh, attributes, and relationships. There are three components of an ER diagram. There is a huge description about ERD. Entity, an entity can be a real world object, either animate or inanimate, that can be, but that can be identifiable. An entity is denoted as a rectangle in the ER diagram. Okay, so, for example, in a school database, student, teachers, classes, and courses offered can be treated as entities. All these entities have some attributes or properties that give them their identity. When we talk about entity set, an entity set is a collection of related types of entities. An entity set may include entities with attribute sharing similar values. For example, a student set may contain all the students of a school. Likewise, a teacher set may include all the teachers of a school from all faculties. Entity set need not be disjoint. Second is attribute. Entities are denoted utilizing their properties known as attributes. All attributes have values. For example, a student entity may have name, his class, and age as attributes, and these exist a domain or range of values that can be addressed to attributes. For example, a student's name cannot be a numerical value, it has to be alphabetic. and a student age cannot be negative. Okay, so these are the examples of attributes. So attributes will justify the entity. Third thing is relationship. An association among entities is known as a relationship, and relationships are represented by the diamond shaped box. For example, employee works at a department, a student enrolls in a course, and here works at the end and enrolls are called a relationship. Okay, relationship set means what? A set of relationship of a similar type is known as a relationship set. Like entities, a relationship two can have attributes, and these attributes are called descriptive attributes. Let us discuss about the state transaction diagrams. These are the example of transaction diagrams. You can see here. Transaction diagrams describes all the states that an object can have, and the event under which an object changes its states means transactions, the conditions that must be fulfilled before the transaction will occur, and the activities undertaken during the life of an object, that is action. So, state transaction diagrams are very useful for describing the behavior of individual objects over the full set of use cases that affect those objects. State transaction diagrams are not useful for describing the collaboration between objects and cause the transactions. These are some symbols you can use when drawing the state transaction diagram. This symbol is used for transaction. This is denote the transaction branch. This is the decision making symbol. End state is this, start state is this, and start is this. So you can easily find out the various uh, symbols. You can use various symbols of state time when you are making the state transaction diagram. State means a condition during the life of an object in which it satisfies some condition, performs some action, or waits for some event. What is event? An occurrence that may trigger a state transaction. Event types includes an explicit signal from outside the system, an innovation from inside the system, the passage of a designated period of time, or a designated condition becoming true. Guard. What is guard? A Boolean expression which, if true, enables an event to cause a transaction. And what is transaction? The change of a state within an object is transition. Let us discuss about the structure design and the tools. There are various tools like structured analysis. There are various tools for structure design also. The structure charts are used for structure designing, and module identification and specification techniques are used when we are drawing the structure design. Okay. Uh, there are some what is the aim of structure design? There is a main aim of a structure design is to make your software reusable. Okay, make your software quality software, which is the main aim of simple software, which is the main aim of structure design. So there are some tools of structure design. First is, let us discuss about the first tool, that is a structure chart. Structure chart represent hierarchical structure of modules. It breaks down the entire system into lowest functional module, describe functions and subfunctions of each module of a system to a greater detail. Structure chart partitions the system into black boxes, and inputs are given to the black boxes and appropriate outputs are generated. Modules at top level called modules at low level. Components are read from top to bottom and left to right. When a module calls another, it views the called module as black box, passing required parameters and receiving the results. These are the symbols of construction of structure chart. Module means what? It represents the process or task of the system, and it is of three types. Control module is there. A control module branches to more than one submodule, and submodules are there. Submodules is a module which is the part, or you can say the child of the another module. And library modules are there. Library modules are reusable and invocable from any module. Okay, so you can invoke library modules from the other module, and library modules are the reusable modules. So this is the clear cut depiction of structure chart. Let us discuss about the module identification and specification technique. When developing and implementing implementation model, and specifically the structure charts, uh, there is a largest task is identification and specification of the modules within the system. As the most methodologies and techniques, there are a few guidelines to be used when developing individual modules as well as when considering the relationship between modules. So there are several methods that can be used by specify a module. Two possible methods of uh, module specification methods are interface or functional method, and second is pseudocode. Interface functional specification provides a good balance of specification detail and is in line with the black box spirit of uh, structured analysis and structured design. The interface, or rather the input and output of the module, provides the details of what the module needs and produces, while the functional specification provides good documentation as to what exactly the module is supposed to do. When we talk about pseudocode is not a programming language. It is a mixture of English, mathematics, and programming constructs formatted so that a human can easily determine what is going on. So uh, there are two module specification methods, basically interface or functional method, and second is pseudocode. So this is all uh, about for structured analysis and structured design. This is a time for assessment through the multiple choice questions. There are 10 multiple choice questions. The first question is these are the sample questions. Uh, uh, Structured analysis and structured design features are obtained from which of the methodologies? So there are three methodologies given in the uh, as options, different options, and all are last option is all of them mentioned. So the right answer is there are, because there are so many there are various methodologies uh, or suggested uh, uh, by the suggested for the structured analysis and structured design. So all are the right answer is D. Which of the following is not an activity of structured analysis? Functional decomposition, transformation of a textual problem description into a graphical mode, and all the functions represented in the DFD are mapped to a module structure. And last one is all of the mentioned. So the answer is all the functions represented in the DFD are mapped to a module structure. So right answer is C. To arrive at a form which is suitable for implementation in some programming languages is the purpose of what? Purpose of structure design. So right answer is B. There are four options: structured analysis, structured design, detailed design, and none of the mentioned. Right answer is structured design. In the next question, the context diagram is also known as zero level DFD. One level DFD, two level DFD, all of them mentioned. The right answer is level 0 DFD. A directed arc or line in DFD presents what? It presents what? It presents data flow. So the right answer is C, data flow. In the sixth question, data store symbol in DFD presents a physical line, physical file, data structure, logical file, all of the mentioned. Yes, all are the databases. So it presents all. The right answer is D. In the seventh question, which of the following is a function of case tool? Support structure analysis and design, maintaining the data dictionary, checking whether the DFD is balanced or not, and all of the mentioned. It supports the structures analysis and design. So case tools are supporting to the provide support to the structure analysis and design. So the right answer is A. A DFD is always accompanied by a data dictionary. It is true or false. It is true. The entity relationship set is represented by in ER diagram as double diagram, undivided rectangles, or dashed lines or diamonds. The answer is diamonds, because you can show the entity relationship set in the presented ER diagram in the form of diamond. The rectangle divided into two parts presents the entity set or the relationship set or the attributes of a relationship set or primary key. The right answer is A, entity set. If you still have any query, then you can consult with these books. These are some reference books. Okay, and now this is all from my side. I hope you can you have understand the what is the purpose of a structured analysis and design, and how what are the various tools of structured analysis and design. Thank you.